Hello, welcome. I hope you're having a great time at RubyConf. I'm so happy that you tuned in for this talk. I'm Stephanie, and I'm the co founder of HexDevs, where I research, design, and develop programs to help you become an expert developer. I'm also a Ruby developer, and I love reading about cognitive science and modern neuroscience, and more specifically, their applications in education. Ever since I found out about perceptual learning in the book Badass Making Users Awesome from Kathy Sierra, I got really curious to learn more about the science behind perceptual learning. I've been doing lots of research on the topic and its applications in education in many domains. So by the end of this talk, you will have learned what does it mean to be an expert, what is perceptual learning, how its techniques can accelerate expertise, and perceptual learning techniques for Ruby developers. Perceptual learning was an emerging field in the 60s with the work of from the psychologist Eleanor Gibson. Her work showed that perceptual learning consists of improvements in information extraction as a result of practice. In fact, perceptual learning is one of the most important components of learning and expertise. If you remember when you were a kid and you learned how to identify what is a dog and what is not a dog, you didn't attend a class, a lesson on what is a dog. You learned how to classify dogs by seeing a bunch of dogs. And once you saw a different dog, even if it was different from the ones that you have seen before, you also knew it was a dog. From For the past 2 decades, perceptual learning has become an area of concentrated focus in the cognitive and neurosciences because of its promising results on accelerating expertise. By this point, you're probably asking yourself, what does programming has to do with perceptual learning? Isn't programming such a high-level cognitive task? Although it may seem like, and even with the example that I used with the dogs, and they might seem simple, such a low level cognitive task, what recent work has been indicating is that perceptual learning is directly related to how we learn more complex domains as well. So, even in high level cognitive domains, such as the learning and understanding of mathematics, and although this research area is relatively new, findings indicate that even short perceptual learning interventions can accelerate the fluent use of structures. We have been talking about perceptual learning and expertise, but what is the relationship between perceptual learning and expertise? Dr. Kelman is one of the lead researchers in the topic, and what he says is perceptual learning underlies many, if not most, of the profound differences between experts and novices in any domain. When we talk about expertise, it doesn't take too long until someone brings up the case of chess players. A chess expert is often mistaken by a mysterious explanation because they can't explain how they know what they know. If you ask them to verbalize all the decisions they make, they won't be able to give you too many details about what's going on in their heads. Similarly, elite athletes are trained to not have to think at all. In fact, if you ask a tennis player or any athlete, To explain their decisions as they perform, they will try to become aware of their actions. And as a result of that, they will perform poorly because they are no longer relying on their automatic pilot. So that shows us that how fast and accurately you perform has an indication of how much an expert you are in a domain. That's why, for example, if you are a novice and you are pair programming with a more experienced developer and you just can follow what they are doing and you ask them, how did you know that? Can you teach me what you know? You often get pretty disappointed with the responses that you get. They will usually say, oh, it's just practice. Eventually you will get it. Or, I just know it. But what does it mean to be an expert? Put simply, expertise can be defined as rapid, automatic pickup of important patterns and relationships, including relations that are quite abstract. They characterize experts in many domains of human expertise. Experts tend to see at a glance what is relevant and what is not. They tend to pick up relations that are invisible to novices and to extract information with low attentional load. In this paper from Dr. Kelman, they show us this difference between novices and experts. You can see here that novices can't quite differentiate what is relevant from what is irrelevant. Whether an expert, they will rapidly pick up the relevant information. Novices will only see simple features, whether an expert will see things in chunks. Novices will process things in a serial mode, whether an expert will have more parallel processing. The attentional load in novices is super high, and in expert is low. And the speed in when a novice is learning a topic is slow and an expert is fast. Does that ring a bell? Do you remember the first time you wrote your first line of Ruby code? You had to figure out so many things at once. You spent lots of time, more than you initially expected, solving syntax issues, trying to decode errors that you had no idea where they were coming from. I just want to say that if that's where you are right now, you're doing great. Embrace discomfort. That's actually expected. You are a human being learning a complex subject. I really like this quote from Dr. Ron Friedman in the book Decoding Greatness. And he says, we don't grow when we are enjoying ourselves. We learn best when we are challenged, struggling, and occasionally failing. Your brain does not see what an expert sees, even though you're both presented with the same information, but that's okay. So when you feel like you just don't know enough to figure out what's going on, just need to reach the point where everything clicks, and that seems it's never gonna happen. You will never understand programming in Ruby. Take it easy, my friend. That doesn't mean you don't have what it takes to be a Ruby developer. It's because you haven't produced better pattern processing skills yet, and not because you don't have a programming brain. There is no such thing. A brain is a brain, and as modern neuroscience has been proving over and over again, your brain is more capable than you imagine. How do we develop these expert skills then? We do that by developing domain-specific changes in the extraction of information. According to Kelman and Massey, with appropriate practice, the brain progressively configures information extraction in any domain to optimize task performance. Perceptual learning produces a variety of effects that fall into two categories: discovery, finding out what information is relevant to a domain or classification. You can see this skill has information selection. As each new instance will differ from the previous ones, learning also includes ignoring irrelevant differences. Fluency, extracting information with greater ease, speed, or reduced cognitive load. So it's not tiring for you to perform a task. You can see fluency has changes in the efficiency of information extraction. So remember the table we saw a few minutes ago? More parallel processing and faster pickup of information. For the sake of making sure that this lesson fits within the allowed time, let's see just one example of a perceptual learning training. In this paper, Perceptual Learning in the Technology of Expertise, studies infraction learning and algebra, they focused on presenting the reasoning and problem solving with fractional quantities in algebra. But we will focus only on the fraction experiment. The goal of the experiment was to help upper elementary and middle school students to recognize and discriminate different types of fraction problems and their ability to map these structures across different formats. For example, word problems, fraction strips, and number sentences. All students attended 9 classes about unit first fractions. It's important to mention that these lessons were focusing on identifying the patterns in the structures when using fractions and not on computing solutions. Once all the students finished this first class on unit fractions, they were divided into 3 groups. The first one was unit first. So after the unit fractions lessons, they were enrolled in a unit first perceptual learning training. Then they had more classroom lessons on non-unity fractions, followed by another sets of mixed unit perceptual learning training. The second group was the mixed unit group. After the unity fractions lessons, they immediately had lessons on non-unity fractions, and then they had a training on both unit and non-unity fractions using perceptual learning training. So they had both more easy and more complex examples of fractions, and then they were just trained with PL at the end. And then the third group, which was the control group, they only had the lessons on unity fractions and non-unity fractions and no training with perceptual learning. The perceptual learning trials for the mixed and unity first groups had 2 to 13 sessions of 30 minutes training each. Here are some examples of how the perceptual learning training was. The participants were trained to discriminate among a set of target structures, particularly ones that may initially be confused with each other. They were also exposed to new and varied instances of fractions. So you can see in this example how they are just asked to match the representation between the target equation with the fraction strip. In this one, you can see that all the choices here that they had to choose, which one was correct, kind of seem similar to each other, and they are close to a representation of the target equation, the word problem. And this is another example of also a word problem and mapping which one of the strips corresponds to it. So the tests focused on the transfer of knowledge by knowing how to solve problems involving fractions and comparing fractional quantities focusing on the patterns instead of computing solutions. The results from the pre-test, immediate post-test, and delayed post-test, which was 9 weeks after the training, can be seen here. We can see that the groups that had training in perceptual learning sets outperformed the control group, but even the control group that had lessons on fractions focusing on the patterns still improved quite a bit. I just want you to focus on the results 9 weeks after the training. The control group retained the learning gains. They had an improvement of 49% of the learning gains after 9 weeks of the training. The mixed unit group was the one that mostly retained the learning gains on fractions, 62%, and the unit first group improved 54%. So the results show that presenting simple and complex examples together help the students develop a more comprehensive and relational way to solve problems using fractions. The lessons on identifying structural patterns as opposed to focusing on solving problems is effective in leading to a better understanding of fractions. And supplementing lessons with perceptual learning training shows significant learning gains. And I wanted to just point out here that perceptual learning is a supplement to educational formats. It's not a total replacement. From these results, we see the brain differently. The mind is seen as a pattern recognizer and not as a container of information. I hope by now you are super fascinated by it. I only had time to show you one example of the trainings with perceptual learning. And unfortunately, no research has been made for programming yet. However, here's what we can learn from what has been published in several domains. There is a better way to practice Ruby. We can practice deliberately. So we can get started by asking, what is the topic to be mastered? What is my goal with this exercise? Once you identify what skill you are working on, measure your performance by doing sets of deliberate practice. To help your brain pick up what matters, get exposure to a wide range of good examples, from simple to more complex scenarios. To measure your performance, aim to achieve 95% reliability, which means every time that you perform these tests, you produce the same results within 1 to 3, 40 to 5 to 90-minute practice sessions. And if you can't get to that performance level, then try breaking the task or skill into smaller subtasks or sub-skills until you get to something you can master within the time. Let's see one example from the book Badass by Kat Sierra. Let's say that you're practicing command line interaction with Ruby. So that's your goal, master command line interaction with Ruby. You already know how to measure your performance. So pay attention on how you perform within the time for the sessions. And you can get started with creating and running programs that calculate and print values based on command line args. If that's something that you can't achieve within 90 minutes, break it down. Modify one code example to use command line args. Run it, make sure you have no errors. If that's still hard for you, you can't achieve that performance within the time, just run sample programs using command line args. Here is another example, very simple one. Let's say that you are practicing the map function with Ruby. Again, make sure to pay attention to your performance. And you can get started with building a list of even numbers from 1 to 100 and filtering out multiples of 3 using the map function. If that's too much, you can't get there yet, then just build a list of even numbers from 1 to 100 using the map function. Okay, that felt like a class, right? So let's see what else we can apply from perceptual learning research to become a Ruby expert. Let's see more practical stuff. The first one is to focus on deliberate practice and not just practice, practice, and practice, as it suddenly magically will get there. Remember, a critical component of accelerating pattern recognition in fluency is to get exposure to a wide range of good examples that embody the relevant structures that you are learning, and not just one or two examples. Remember to find a variety of contexts using the skill that you're practicing. Master the basics. Really, baby steps. It's better to know the basics well than have surface knowledge about a couple of things. The better you master the topics, the more you are freeing up your cognitive capacity to focus on higher level problems. If it still takes you lots of time and effort to complete a task, or you're just following tutorials without really understanding the goal, you won't advance to the next level as much as you expect. Go easy on your brain. It's cognitively costly to master a topic. So remember to be kind to your brain and take breaks after each deliberate practice session. Embrace discomfort and getting stuck. When you reach the point of, oh my god, I'm so stuck, I suck at this, there's actually a lot of information for you to take action. You are probably trying to rush a topic or missing a crucial step. Learning what you don't know yet is not bad, it's information. You can ask yourself, what am I missing here? Asking open ended questions like this gets your brain picking up on clues, and it's way more actionable than just announcing your defeat. Always be sharpening your knife. Experts are always identifying what skills they are not fluent in yet. It doesn't matter how many years of experience you have, there's always room for improvement. So, to summarize the perceptual learning techniques for programming, remember to find the right blend of introducing facts, concepts, and produce procedures, along with accelerating pattern recognition and fluency through perceptual learning technology. And that is likely to be of maximal benefit to learning in mathematics and many other domains. Well, I hope you're inspired to give it a shot. Let's do a quick recap. So, we learned that expertise is available for everyone. We learned that you can accelerate expertise in any domain, including programming. We also saw examples of how to adapt your practice to follow a more deliberate practice. There are a few things that I don't have the answers yet, and I'm really looking forward for finding the answers for them. And the first one is, as we saw in the examples, the perceptual learning trainings mostly rely on visual representations. So it's not clear how it can be adapted to people with visual impairments issues. There is also no published research using perceptual learning technology with programming until the recording of this talk, but that's our focus at Hex Devs. It, sorry. It's also not clear how much of the trials, design, and procedures have to be followed for perceptual learning to be effective in a non experimental environment. You made it! Congratulate yourself for getting to the end of this talk. That was a lot, and it's normal if you feel overwhelmed. So take a break, revisit this talk a few days later. Take your time. By now, you know best how to work with your brain and leverage on the signs it gives you regarding your cognitive resources management. Let me know what surprised you and what you're looking forward to try. Thank you for watching this talk. I also just wanted to say thanks to Tiago, my partner in crime, uh, everyone from the women community. Thank you so much for the support. And thank you for watching this. If so, let me know what surprised you and what you're excited to try. And the slides and the resources and a written format of this talk can be found at hexdevs.com/RubyConf 2021. See you. Bye.